Hello, this video is for digital signal processing assignment 1, which I'm required to compose square, triangle, and sawtooth wave by using sine wave with frequency 1 Hz from scilab. I am also required to load the wave file, plot the sound signal, and print a wave file factor, frequency, and frequency. So, all the resources that I'm using are given here. These are square, triangle, and sawtooth wave resources where I get the equations from. Moving on to the plotting. Here is the code for the square wave with frequency or range is 0 to 1. And according to the original equations, I'm just producing more sine waves here. These are multiple sine waves with different k variables value. And to produce square wave from this sine equation is by adding all of them together. So these are all the equations with different variables value, and this plotting area here is where I am showing every single equation that I have added here with different defined colors. We'll see later. And the y total is where all the equations are being added together. Y after y, y8. So this is the final wave equation that I am going to plot, which will show a square wave. And finally, the wave file will be uploaded and saved into my directory. So I am going to execute this. So these are all the sine waves from the code. The blue line of the sine wave is the original, which is on y here. And the final one is this red wave, which I said that it is clear as a square wave, but it can get more clear and sharper square wave if there are more equations being added together. So, moving on to the sawtooth. I'm just using the same method and concept, but with different equations and also additive synthesis. For sawtooth, I am producing a lot. There's 8 equations here. I'm going to add them up together, and they use a bit different method, which they combine both subtraction and addition. So, first I am going to show how the signal look like if I'm using the equation. This, then so this is how it looks like with 4 equations. I am going to calculate them using 8 equations. I'm going to change it to blue color so that we can see the comparison. So the blue color is the one with more equations involved. You see that it is more sharper and the shape are more clear as a sawtooth wave. So the more equations that is involved are better to get clear waves. So for the triangle wave is also the same as 2 of the previous wave. using the same additive. So this is a sawtooth with, you can see a clear red line triangle loop here. Finally, I have recorded an audio, which is mining assessment, and I converted it to a WAV file. So here is a code to call the file and then plot the signal. So here is what it looks like. How the rate of that frequency. That is all for me for this video. Thank you.